Hey guys, this lesson is about special right triangles. It's kind of a preview to chapter 8. So normally I'll have people kind of look at this before we start chapter 8. So we just finished chapter 7 test, and this is kind of a preview of some algebra sort of things that we need to know before we can start chapter 8. So this will be on your quiz next week. So make sure to pay attention and then let me know if you have questions. And then we'll go over the homework on Monday. So watch the video, do the homework, and then when I see you next, we'll talk about it. Okay, here we go. Special right triangles. We're going to look at right triangles. The way we know it's right is this box right here. And we're going to be doing a lot with triangles in chapter 8. And so these are just some that are used frequently. And so they teach kind of some shortcuts. Good news and bad news. We're not going to be using decimals. We're going to be using stuff with the square root. So that might be bad news for you, but that's how they do it on the ACT. So I'm trying to get you guys kind of in the hang of that. So our first right triangle that we see a lot is an isosceles triangle. It's where this side, and they just called it S, is the same as this side. So when it's a 90-degree angle, which is a right triangle, and it's isosceles, then the rest is just 45 and 45. So what they want us to see, and I'll show you why this works. Let's say this isosceles triangle has one side of 3, and then this side is 3. So using the Pythagorean theorem, we'd say 3 squared plus 3 squared equals c squared from this. And that'd be 9 plus 9 equals c squared. 18 equals c squared. And then this is the tricky part. When you square root it, you would get some sort of decimal. The ACT is not going to want you to do a decimal, so you break it down. 18 is 9 times 2, so the square root of 9 and the square root of 2, which the square root of 9 is 3, and then the square root of 2 is some kind of decimal. So if you type square root of 18 into your calculator, you'll get a decimal, but this is what the answer would be without the decimal. So you can do all of this work every single time and all of this difficult stuff that might stress you out, but there's a nice shortcut. What they're saying is if you have a right triangle with 45 degrees and 45 degrees, since it's isosceles, this and this will be the same. And they're saying the shortcut for the hypotenuse is it's going to be whatever the side is times the square root of 2, just like we saw here. So it's a nice little shortcut if you don't want to do all of this where you don't have decimals. So just a random one. If you have this isosceles triangle and this is 8 and so is this will just be 8 times the square root of 2. And then you don't have to do all of this. So here's our shortcut. The hypotenuse is the square root of 2 times one of the sides of the triangle, or the leg. So the hypotenuse is the square root of 2 times one of the sides. And that is only if you have a right triangle with 45 degrees, and then the right angle. So these are just some super specific cases that are we have some shortcuts for. So 45, 45, 90, this is your shortcut. The hypotenuse, which is the longest side, is the square root of 2 times one of the other sides. There's another type of triangle that we see fairly often, and it's a 30, 60, 90-degree triangle. This is that triangle. I'm going to show you. These are going to be our two shortcuts. So the hypotenuse is always going to be 2 times whatever the shorter side is. And then the longer side is gonna be the square root of 3 times the shorter side. And I'll show you guys where that comes from. So this triangle was an isosceles triangle, and it was kind of a theorem based on that. And another triangle we see often is an equilateral triangle. So this theorem is based on that. An equilateral triangle, they're all 60 degrees and 60 degrees. None of these are a right triangle, but if I draw a line straight down the middle, then this is going to be a right angle. And then, of course, so would this. So when you draw the line straight down the middle, that makes this side 30 degrees and this side 30 degrees. So now if we look at it, I'm just going to erase this half so we don't have to worry about it. Now we've got our 30, 60, 90 triangle. So that's where it comes from. It's just an isosceles triangle cut in half. So an isosceles triangle, all the sides are the same length. So let's just make up, let's say that's 2, this whole thing would be 2. Which means this half is 1 and this half is 1. So when I go back and, like I was saying earlier, if we just look at half of it, then we have this side, which is 1, this side, which is 2, and this side, which we don't really know, but we could do Pythagorean theorem, a squared plus b squared equals c squared. And we could solve a little bit of Pythagorean theorem, and b is the square root of 3, which is some kind of decimal. This is where this rule comes from. So we can see now the hypotenuse, which is this side, is twice as long as the short side. 1 times 2 gives you the hypotenuse, which is 2. And then we'll also notice that this longer side is just the shorter side times the square root of 3. So I just wanted you guys to kind of see where these shortcut rules came from. So when you have an equilateral triangle, and you just cut half of it off, you're just looking at the left side or the right side. And then when you have an isosceles triangle. So recap, these are our shortcuts. So if you have a 45, 45, 90 triangle, or basically an isosceles triangle, then your rule is if you take one side and you multiply it by the square root of 2, that's going to equal the hypotenuse. Then if you have a 30, 60, 90 triangle, which is an equilateral triangle where you just took half of it off, then if you take the shorter side times 2, that's the hypotenuse. And if you take the shorter side times the square root of 3, that's the longer side. I just am missing Christmas. I suppose I should make these spring colors. I still have my Christmas tree up, you guys. Is that embarrassing or what? This is springy, right? Ooh, yeah. There we go. So I'm just going to copy and paste these, and I'm going to use them everywhere. So that's the basics of the shortcuts. Now we're just going to do some practice problems. This is kind of what will help you on the ACT timeline-wise, if you only have a minute per problem. We'll go purple. Nope, we'll go. Shout out to Sabrina for these colors. Okay, so this one's a 45, 45, 90, which means we're going to use this rule. And they said find the value of h, which is the hypotenuse in this case. So all we got to do is say the square root of 2 times the side, which is 8, is the hypotenuse. So h equals 8 times the square root of 2. And that's it. So the shortcuts might be hard to remember, but if you have them, then it's not too bad to solve and pretty quick for the ACT. Here's another one that's 45, 45, 90. So we'll use this rule. This time they're making us work a little bit. They gave us the hypotenuse, which is 5 square root of 2. And all we got to do to figure out what the side is divide by the square root of 2 on both sides. Those cancel, and the side just equals 5. So the shortcuts are pretty fast once you have them down. Copy and paste. We'll use this over here. Okay, this one again is 45, 45, 90. So I'm going to use this rule. And it looks like they gave us the hypotenuse, which is 10. And we need to figure out what the side is. So divide by square root of 2. And the side is 10 over the square root of 2. One little note, that's fine, that answer. The ACT does not like square roots on the bottom. They just don't do it. So if you want to practice for the ACT, what you would do is you would multiply it by 1 on each side. And so that you'd have side equals 10 over the square root of 2 times 1. And 1 is the same thing. Square root of 2 over square root of 2 reduces to 1. So I could rewrite it like that. And then I can say the side is 10 times the square root of 2 over the square root of 2 times the square root of 2. And the square root of 2 times the square root of 2 is the square root of 4. And the square root of 4 is the number 2. And 10 divided by 2 is 5. And this is what the ACT would write the answer as. So if that just went way overhead and stressed you out, no problem. You can give me this as your answer, and I am okay with that. But if you want to notch it up and prep for the ACT, this is what you would have to do. Okay, let's try some more. Am I a nerd? I'm kind of thinking this is fun. I just like how quick it is. Okay, so what's the height of an equilateral triangle? Okay, so that's meaning we're probably going to do this rule. Change my colors. An equilateral triangle. So 60, 60, 60. And then if I cut it in half, just a reminder from before. Then this is a right angle. And so is this. And then that 60 degrees turns into 30 and 30. So if we cover up the left side, we kind of have our 30, 60, 90 triangle. So it said each side is 12 centimeters long. So they said, what's the height of this triangle? So instead of having to do Pythagorean theorem, we could just say, well, 12 cut in half, that's 6 and 6. So the height of the triangle, and again, if we just kind of look at one of the sides, we're just finding this height here. We can use this shortcut. So if we want to find the longer side, we can take our rules. This one has something about the longer side in it. And our shorter side is 6. And that's our answer. The unit would be centimeters. I think that's what they said. So a little bit hard to memorize. You might just like doing the Pythagorean theorem, but for speed on the ACT, this is what a lot of people will use. Okay, we have 2 more problems. So a courtyard is shaped like a square. I don't know what rule we're going to have to use yet, so just use green. A square, and each side is 250 feet. They want to know the distance from one corner to the other. So the question here is, which type of angles do we have? Well, if it's a square, we know this is 90. Well, if I can draw it, this is 90. All 4 are 90 in a square. And then if that diagonal cuts that square in half, we're going to have 90 divided by 2, which is 45 each. So I like to kind of erase the part that I don't need so it doesn't stress me out. And I'm just kind of looking at this triangle now. So I'm guessing we're going to be using this rule because I see 45, 45, and 90. So the square root of 2 times a side is the hypotenuse. So the side is 250 feet, and that's the hypotenuse. So I'll just write it. I like to write the big number in front and then the unit. And then you know your answer without decimals, which is what the ACT wants, and you didn't really have to do all that much work compared to the Pythagorean theorem. If you didn't like the shortcut, you would have had to do 250 squared plus 250 squared equals c squared, and you'd get this in your calculator, and you'd get this in your calculator, add them together, and you'd have some really big number that you'd have to deal with trying to figure out the square root. And that seemed too stressful, so I like this shortcut. Again, you're welcome to do it this way. It's just difficult to deal with such big numbers, especially without using any decimals. But up to you. Okay, last one. This is very obviously a 30, 60, 90 triangle. So I'm going to go grab my shortcuts. And they want to know the value of x, which is the shorter side. Now, both of these formulas involve the shorter side, but it doesn't look like I have a number for the hypotenuse here. They didn't tell me. So I'm going to go with this rule. The shorter side equals the square root of 3 times the longer side. So our shorter side is x. We don't know what that is. Times the square root of 3 is equal to the longer side, which is 15. So divide both sides by 3. And x equals 15 divided by the square root of 3. And again, you could have done x squared plus 15 squared equals c squared. But they didn't even give you the c squared. So this is a nice way to be able to figure it out. If you want to really prep for the ACT, remember ACT does not like a square root in the bottom. So they would say you can multiply each side by 1. And that would give you x equals 15 over the square root of 3 times 1. And 1 is the same thing as the square root of 3 over the square root of 3. That would reduce to 1. So I'd have 15 times the square root of 3 over the square root of 3 times the square root of 3, which would be 15 square root of 3 over square root of 9. The square root of 9 is the number 3. And 15 divided by 3 is 5. And so this is the answer that the ACT would have. It's called radical form. I'm fine with this, but if you want to, with this answer right here, but the ACT would have this as one of their answers. So depending on how much you want to push yourself. So this is just a preview of, we're going to be doing a lot with right triangles this next chapter. And I just wanted to show you guys a couple of the shortcuts that are used a lot on the ACT. And if you don't have enough information in a problem, sometimes this will help you figure things out. And basically, these are our shortcuts. So we kind of need to know this to be able to jump into chapter 8. So that's why I had you guys work on that today. Your homework is this right here. It says 5.8. We actually skipped it in chapter 5, but it's getting us ready for chapter 8. So call it what you want, 5.8, 8.0. I think I might have put it on Veracross as, but it is this, and it's in Canvas. Let me know if you guys have any questions. Have a good long weekend. See you guys. Bye.